Geometric growth and decay, explicit form. Recurrence relations for geometric growth. Here is a sequence for geometric growth. 2, 4, 8, 16, 32. We want to know what the third term is going to be. So in this case, we know it's 16 there, but we want to make sure we can actually work it out. So here's our recurrence relation. We have our initial value, which is 2, and each term after that, we're multiplying it by 2. Initial value is 2. Our next term after that is 2 multiplied by the initial value, which equals 4. V2 equals 2 multiplied by V1, which is 2 multiplied by 4, which is 8. And it can be rewritten as 2 multiplied by 2 multiplied by the initial value. So here we go. Now we're just going to keep going to the third term. So the third term equals 2 multiplied by the second term, or V2, which equals 16. So 2 multiplied by 8 is 16. And now we have 2 by 2 by 2 multiplied by the initial value, which equals 16. And as you can see, there's a pattern emerging. So this value is the same amount of times that the common ratio is multiplied by itself. Okay? So you see the 3 there, and that 2 is being multiplied by itself 3 times. So therefore the third term is 16, and we've got that common ratio of 2. Now as you can see in the previous term, you can see that pattern still there. So for V2, that is basically 2 multiplied by 2 multiplied by the initial value, okay, which was 8. So it's still apparent there. So finding the rule for the geometric growth. Now we've got our third term, and now what we can do is simplify 2 multiplied by itself 3 times as 2 to the power of 3 using index laws. And then that's multiplied by the initial value. So therefore we've got Vn equals 2 to the power of n multiplied by the initial value. And that can be used to find any term in that sequence. So therefore the explicit form, or the rule for the nth term, is Vn equals the common ratio to the power of n multiplied by the initial value. So the explicit form for geometric sequences, we've got geometric growth, which is Vn equals common ratio to the power of n multiplied by V0. The difference is that R, or common ratio, equals 1 multiplied by add the interest rate divided by 100, and it is always, or the common ratio is always above 1. Geometric decay, the explicit form or rule, as you can see it looks exactly the same, except the difference is the common ratio is simply 1 subtract R divided by 100. And therefore the common ratio is always going to be less than 1.